Hi, everybody. We're going to get started. All right. Thank you very much. Glad to have you joining us. My name is Sarah Hindlian. I am the Senior Software Analyst at Macquarie. I've been in the industry either building or analyzing software for 17 years. And I am very excited to have today our edge computing panel. We have David King from FogHorn with us today. And we also have Dr. Irene Petrick from Intel with us today. And Michael Dolbec of GE Ventures also. And you know, I'd love it if you guys could each spend maybe just a minute or two going over your backgrounds and what your roles are today before we dive into any topics. Why don't we start on the end?
Okay. So FogHorn Systems actually is a portfolio company of both GE Ventures and Intel Capital. So we actually have other investors as well, including Dell on the technology side, Honeywell, Bosch, Yokogawa, and most recently Saudi Aramco, who led our last round. So I just came from Houston at a big oil and gas conference that you might have seen on television. So FogHorn's technology is what we call true edge computing. And when we say true edge, what we mean is a lot of folks are trying to repurpose what's been developed over the last 10, 20 years in the cloud in terms of data science, machine learning, AI, deep learning, and analytics, and kind of shrink it into either a data center or a big server format and try to get all the sources of data. We're trying to do something a lot more disruptive, which is to literally take the power of what's been done in the cloud and shrink it down to the smallest possible footprint in terms of compute resource and memory consumption. And so we can run our stack to do analytics, machine learning, AI, deep learning, literally on the machine. So it could be in the control system that manages the machine. It could be a little Raspberry Pi gateway that can manage multiple machines. And so really it's the idea of getting access to the data at the very, very source. And this could be any kind of sensor data. It can be video, audio, LiDAR. It doesn't matter what the data source is. Contextualize that with other obvious reference information and basically be able to make decisions on the fly. Right? So latency, bandwidth savings, storage, persistent cost savings, but even more importantly, much higher fidelity predictions and models, because you're not averaging things out and compacting to ship it somewhere else to go figure out what's going to happen. You're actually taking the live data as it's produced and making decisions on that basis.
All right, fantastic.
Wow, that was really extensive. I don't think I can match that. I'm Mike Dolbec. I've been a venture investor for 30 years, 5 with GE, but various corporate venture activities as well as 2 institutions. I started my venture career with Kleiner Perkins and with Greylock. So I've always been involved in emerging technologies in AI, mobility, this thing called the internet, which I think is going to be really big someday. And lately with the digital transformation that GE is enjoying itself, but also trying to accomplish on behalf of its customers. And so the reason that we're investors in FogHorn has a lot to do with the vision that we had for helping our customers exploit the tremendous amount of data that it's possible to collect, but difficult to effectively monetize because it's never where you wished it was, and it's inconveniently expensive to move it sometimes to where you wished it was, or you don't have enough time before you'd like to make a valuable decision. So that's me.
Good morning. I'm Irene Petrick. I have been with Intel only 2.5 years. Before that, I was a professor at Penn State. So I've spent most of my career actually looking at technologies that are 5 to 10 years out. I, at Intel, direct business strategy in the Internet of Things group, primarily in the industrial space. And I'm sitting with these 2 gentlemen, all of us passionate about that compute at the very edge. Believing that that's really where it's going to go.
That's very interesting. So let's talk about this because, computing at the edge, I think, is really critical, especially in a world of IoT. But it's not uncommon for me to encounter investors who don't really understand how companies can leverage computing at the very edge and also cloud at the same time. So I think one of the things I'd love to hear about from each of you is how you address that. How do you think about that? And how you generally use the cloud in looking at edge, which I think is obviously something that's quite doable.
Sure. Yeah, so virtually every use case for every scenario, there's a role for cloud and for edge.
Yep.
And where IoT developed over the last 5-10 years, coming out of M2M or machine to machine in the kind of commercial enterprise setting, really was preceded by a lot of kind of consumer-oriented IoT applications, right? So smartphone applications, wearable devices, Nest thermostats, kind of focused in on kind of everyday consumer use of the technology. And so it grew up in parallel with the big data trends, right? Massive compute in the cloud environment. And so that's where I think the picture's changed the last few years. The focus is no longer just on consumer applications. We're talking about really industrialized applications. And so when you start talking about manufacturing, oil and gas, mining, agriculture, smart buildings, smart cities, the mantra, and I borrowed this from GE, the volume, the velocity, and the variety of data types we're talking about.
Yep.
Volume meaning, if you've got video cameras and you've got 3D imaging, it's just way too much data to be shipping across the network to figure out what's happening, right? And persisting that data is also incredibly expensive. The security is also a big issue. The velocity, we're talking about what they call high frequency data, right? These are sensors. You may have several thousand on a jet engine or turbine producing data every 10 or 20 milliseconds. Again, big problem trying to transport all that somewhere else. And the third is the variety, right? This is what the OT people call dark data. We call it dirty data, right? This is not easy to consume data because the sensor
or missing data altogether.
Yeah, exactly. You have sensors that are operating in very ruggedized, high temperature, high pressure environments. Sometimes they don't work properly. So how do you contextualize? How do you clean up that data? How do you normalize it? How do you condition it? But even more importantly, how do you align that so you can actually apply the big data science, the analytics, machine learning, AI algorithms, because they have to be perfectly aligned to run those models properly. Otherwise, it's garbage in, garbage out. And so what we've seen essentially is now that people are talking about IoT in the industrial context, which is where GE really took a lead role with Petrick, and the whole industry is now kind of following along, is really identifying it's a different kind of compute model. The cloud plays a big role for what we call the digital twin for the fleet, but the individual asset digital twin should actually be running right next to the machine, next to the process.
You asked, or you made the statement that investors have trouble processing the concept that, well, they think they understand cloud computing and why that is important and how to make rational investment decisions based on that playbook.
That's right.
How people have been
Edge
successful.
Is a little bit less clear to them.
And you also asked, how do I think you asked this, how do I as an investor deal with that issue myself? And so the real answer is I had an unfair advantage because my company had a strategy that I first read about 5 years ago that included this concept of not just edge computing, but a sort of series of edges. That computing ought to happen at some appropriate place, not always in one central location. And there were, even back then, some very good economic and latency reasons why it didn't necessarily have to happen in the cloud, even though that's the way everybody was used to it. So my unfair advantage was I was, in some sense, comfortable with the fact that we had that strategy, that we'd already socialized that with our investors, so we knew, in some cases, we'd already promised it to our customers. And I knew that we just had to accelerate that. So I don't know if it's an unfair advantage or a forced march, but it was clear that it was going to happen. We were going to spend a lot of money on it. We had talked to customers about it. We had an enormous amount of customer requirements because we had asked them to imagine, what if this was possible? What issues would you have in adopting it? And that allowed us as investors, it really informed our perspective. And again, circling back, we have a number of investments in edge computing, but one of the reasons we financed David's company is because it solved some crucial issues we knew were very important to customers. And frankly, we were trying to solve those ourselves, and then we watched David's company out-execute us, and we realized everybody's in a big hurry, we better switch horses and start forming a partnership with them.
Where was it in particular that you saw FogHorn really pulling ahead?
Well, it's the flexibility. It's not that you can do computing at the edge. In some sense, that's been possible for quite a long time. I think it's the flexibility of how you can selectively move workloads to the edge, manage them en masse, because it's not just one edge, it's tens of thousands of edge things. There's a management issue. There's a reliability issue. There's a security issue. So it's sort of like what happened with data networking all over again. Once there's just not a mainframe and a bunch of dumb terminals, you have smart things at various orbits further and further out. There are very exciting things that are possible, but you just created a whole new set of problems you have to deal with, which are opportunities for entrepreneurs.
Irene?
So I think that when we make the distinction between the edge and the cloud, we assume it's an either or. At Intel, we're saying it's an and. There are certain kinds of things I need to process at the edge because of latency or because of bandwidth. There are certain things I need to process in the cloud because I've got to pull across multiple kinds of data streams. And I have the luxury of time then to push down more sophisticated analytics back to the edge. So I think that the notion that compute should only happen at one particular place is probably not true, and I think our sophistication will grow around that. We prefer to think of it as dynamic compute. I have the compute where I need it, when I need it, for the specific purpose that I need.
Sure.
We tend not to ask that for the purpose as much as probably we should be.
Right, and the next, well, I don't know if it's fair to say the next thing, but one of the important issues to wrestle with is if you could do computing at a variety of places, is that hard-coded? Do you have to decide that in advance? Will this kind of follow the path that load balancing followed, where some intelligent thing based on policies decides where the workload should happen right now, and if things are really gummed up, it should move the workloads around a little bit? You can kind of look at the history of how data networking evolved, the issues that came up in each round of evolution, the solutions that were developed to solve those problems, and the new things that they created. And you can kind of guess where edge computing might be headed next, because it's sort of creating its own next set of problems each time we solve something.
Yeah, I completely agree. I think the idea of this kind of continuum, right? Sometimes you'll have 2 layers, just edge and cloud. Sometimes you'll have 3, what Dolbec refers to as edge, core, and cloud, an on-prem kind of compute plus the cloud. In autonomous driving and some more advanced use cases, you're going to have 4 or 5 layers, right? You're going to have multiple compute sources in the vehicle. I mean, like Michael Dell's analogy of when the deer jumps in front of the car, that decision has to be made right there, right? There's lots of other use cases, though, in autonomous driving where at the mesh level in the network or at the cloud level, you're actually making the decision about optimizing traffic flows and coordinating, city infrastructure and such. So, you're going to have scenarios where it's 2 layers, sometimes it'll be 3, sometimes it'll be multiple layers. And this idea of being able to put the compute, as Irene describes, at the appropriate place is absolutely correct.
But I think the really interesting piece, it's not really just an IT problem.
Right.
It really is an operations problem.
Yeah.
So you've got to have a deep understanding of your processes, of the analytics associated with success at every stage in that process, which means that the operations people that are pesky in our lives now become essential, and the IT people who are pesky in their lives become essential. And we have yet to see that real convergence and merging. We see it in certain companies, but I think that that's going to be an essential piece to really get that dynamic compute figured out.
The other thing that, sorry to interrupt you, but
No, please.
one thing that I guess that we discuss, or I brought up at board meetings, is that there's how do you edgeify? You know how to build and manage and operate a central solution. And it is attractive for a variety of reasons to move some or all of that out to these various levels that we described, the possibilities in edge computing. Great, so it's cool and you could do it if you wanted to. How do you do it? How do you how do you build an organization that knows how to do that? How do you break up a problem? So just think about edge and core. How do you take things that have always happened in the core and a workflow, a way to solve a problem, and take pieces of that and decide which parts ought to happen at the edge? And when, if ever, some epiphany that happens at the edge gets shared with the core, that just learning what's the new workflow? How do you design a solution around that? How do you actually operate that? How do you know that it's working well or not working well? How do you debug it? Those are all interesting opportunities, I think.
By the way, to pick up on those last 2 points, I love the term, edgifying, or edgification, we call it now. Mike created that in a board meeting about 5-6 months ago. To put a finer point on that, what do we mean by edgifying, right? The notion is, if you take what's been built in the cloud in big data the last 10 or 20 years, you've been talking about infinite compute environments where you can put as much compute, memory, and storage, so you didn't have to be particularly efficient in how you code it, right?
There's no power budget,
Right.
there's no memory footprint.
Right. And so when you get to the edge, there's no infinite compute. In fact, it's very defined, very constrained compute. You're talking about devices that may have a gigabyte or less, a half a gigabyte, a quarter gigabyte of memory, and you're trying to do what you do in the cloud in 100 gigabytes of memory. So the edgification isn't just the fact we wrote a stack that can run in this tiny compute environment and a whole stack can be deployed, but the way you write the models, the algorithms. So if you're writing in Python or you're writing in SQL or you're writing in Lambda,
Not particularly
you're writing
performance,
10s, 20, 30,000 lines of code just to do pre-processing at every stage. So you end up with these big bloated stacks, if you will. You can't fit them in the edge system. So this idea of having an edge stream and streaming analytics semantic actually was one of the critical breakthroughs. And to Irene's point, when you talk about edge as opposed to a lot of the cloud-based IoT applications, you are by definition right at that IT-OT interface or OT-IT interface. You're right there, right at that seam, because to actually get value out of our stack, we have to understand the processes. We have to understand the business problem, right, as well as the operational challenge that the OT people face, right? And so by definition, we run into obstacles all the time of OT people saying, I'm not sure I want you messing around with, not just touching my control system, because we're not going to touch it, but hey, this is my domain, right? Why can't I reprogram my PLC? Are you really going to try to change our workflow? And so we see that literally every single use case. So we have to come in with a use case that has value, right, to the business operations side, and it has to have enough data sufficiency, right, to solve the problem. Because then you don't want to waste months and months and not be able to identify the failure condition or the anomaly. So it's a challenging environment, but what we think we're doing essentially is showing the path towards what I call leveraged payback, right, for the investment. Because if you can solve a business problem, rather than take on the whole company's challenge of the operations across the board, you're solving one high-value use case at a time.
Thank you very much. We have a couple minutes left. It's very rare to get so many great minds on a topic together at once. So is there anybody in the audience that has a question they'd like to ask? Please.
This is to David. David, do you currently or do you anticipate using AI to determine where the compute happens and the dynamic?
You should probably repeat the question.
Yeah, so the question is, are we using AI to actually make determinations about where the compute happens? We're not quite that far along in terms of the maturity of these multi-layer stacks. We've done several dozen.
Write that down, that's a good idea.
Yeah, we've done a lot of use cases now in manufacturing, oil and gas, smart buildings, transportation, are probably the 4 areas we've done the most work in. And right now, as I said, we're starting out on these, when I identify them, Saudi Aramco has a great term for them. They call them hero use cases. Because you have to come in and identify things that the operations people say are of value and that they can't do themselves. So we're doing things with video and with imaging, with laser that you would just blow your mind in terms of the geospatial drill bit positioning to millimeter level of specificity, mile underground mud composition analysis, right, where you can't even get the data back up to the surface. So there's an amazing number of things that we're working on. We haven't yet matured to the point where these use cases have gone to scale, other than we're working with the world's largest elevator company that's going to go to scale in a million and a half plus elevators and escalators all over the world. And those are the kind of use cases that will definitely, we're trying to put as many of the ML algorithms right at the edge, because that little control box that's half the footprint of a Raspberry Pi has to do the controls and has to do all the analytics. And we're talking about dozens and dozens of algorithms running simultaneously. Right? You build the algorithms in a data center or cloud, but you have to push and execute, do the inferencing at the edge. So there will be this, and you're exactly right. This is a good, one of the best uses of AI. We actually use a lot of machine learning in our own stack, and I'll give you an example. So when we plug in now, we have what we call automated sensor discovery. Well, how do you make decisions about what this digital data types, is this temperature, is this pressure? We're using machine learning, right, to figure that stuff out automatically. So we are leveraging that in our stack, but this idea of kind of multi-layer provisioning is not yet occurred.
One last question. You mentioned that Python, for instance, what language do you guys use?
Well, the platform itself, right, which is in total about 150 megabytes of total memory for all the different components, excluding a TSDB, which ships optionally with it, is all written in C and C++. Right? So we've gone back to old embedded languages, right, because you have to.
But you
What
have
was that?
a language that describe and train models.
Yeah, so we had to write our own, people always say, why'd you write your own language? And the reason is that, SQL, Python, any of these higher, more abstract languages are not anywhere near as efficient in terms of execution time and footprint. So we had to write a streaming, they call it reactive stream processing language, to operate on this kind of infinite dirty data set, right, in real time, right? So the data's coming at you permanently. It never stops. And you have to make sense in real time, contextualize, clean the data, normalize and condition it, right? And then apply your data science logic to it, all in a millisecond or two. So it all has to happen. So we had to write a new kind of semantic to be able to do that.
Anybody else? Please.
Quick question. The example with the elevators and the escalators, you're going to have someone who build the infrastructure the last mile. Who does it in that sense? They have that already in place, or do you have a partner to build that?
Well, in that case, the customer is actually, and we thank GE for the introduction, is actually the elevator manufacturer itself. If you actually think about that business, it's actually elevator as a service, right? The owner operator.
It's vertical mobility.
Right.
As a service.
You don't pay for the capex in most places. You're paying for a 20-year service contract typically to operate it and make sure that there's uptime, right? That you have the SLAs that guarantee that the thing works properly. And so there, the whole idea is to bake the logic, if you will, into that little control platform that runs the elevator, so that if you identify anomalies, like it's not moving fast enough or the door's not opening and shutting properly, even without video, although that's coming into the picture later. But the legacy elevators out there typically don't have a video camera that's watching, if you will, unless it's a security camera. Right? So you're basically taking whatever your sensor data is in that, it's usually about about a dozen to 15 sensors, but you want to process every possible permutation combination to figure out, is the, with the altimeter, the accelerometer, is this thing working properly, and do I need to send a technician out? You've all seen the IBM ad, right?
It's like the IBM ad, only it works.
Exactly. It's actually real, right?
It's real. Yeah.
Exactly.
All right, well, we are out of time. Michael, David, Irene, thank you so much for joining
Thank
us
you.
today. We're really appreciative of your time. Thank you.
Thank you.
Thank you.